While the most common way to make esters is using the Fischer esterification, which starts with a carboxylic acid, it's not the only way to do it. And another way we can do it is if we start with an acid chloride. In some ways, this can be an even easier reaction because we don't need to use the harsh acid of the Fischer esterification. The negative, of course, of this reaction is that it usually requires that we have to make the acid chloride first. All that being said, if once we have the acid chloride, the esterification reaction is pretty straightforward. So with any acid chloride that we can form, given the electrophilicity of the acid chloride, we don't usually need to do any sort of activation of the carbonyl. It's already been activated by the presence of the chlorine. So typically adding the alcohol itself is sufficient to trigger this reaction. The oxygen of the alcohol attacks the carbonyl, pushing the electrons up onto oxygen. This forms the tetrahedral intermediate that we see in every acyl substitution reaction. And then, as we always see in these types of reactions as well, we kick out the leaving group. We do that when the carbonyl reforms, the chlorine leaves, and we formed our ester, albeit the oxygen that was the alcohol is still protonated. So one final step, loss of that proton. Yields our product.